What happens to the sky tonight if the sun didn't move around us, but we moved around it? For most of human history, nobody could answer that question honestly. They just assumed the opposite was true.
For over 1,000 years, the dominant model of the universe placed Earth firmly at the center. Everything else, the sun, the moon, the planets, the stars, was believed to orbit around us in perfect circles. This wasn't a fringe idea. It was taught, defended, and enforced. Let's start with where this idea actually came from. In the 2nd century CE, the astronomer Ptolemy compiled a mathematical model of the cosmos in a work called the Almagest. It placed Earth at the center, with the sun, moon, and 5 known planets circling around it on nested spheres. To explain oddities like planets appearing to move backward in the sky, Ptolemy added smaller circles called epicycles, circles riding on circles, to make the math work. And here's the strange part. It worked. For over 1,400 years, Ptolemy's geocentric model successfully predicted the positions of planets well enough for navigation, calendars, and astrology. It wasn't obviously wrong. It was just built on a false premise that happened to produce usable results, at least for a while. So, what would it actually mean if Earth really was the center of the solar system? First, the physics itself would have to work differently. In a genuine geocentric system, the Sun, at roughly 333,000 times the mass of Earth, would need to orbit a much smaller object.
Under Newtonian gravity, this doesn't happen. 2 bodies orbit their combined center of mass, and when one object vastly outweighs the other, that center of mass sits almost exactly at the heavier object's core. In our real solar system, the sun barely wobbles because of Earth.
For Earth to be the true center, the fundamental rules of gravity would need to be entirely different from the ones that govern everything else we can observe, from binary stars to galaxies. But let's set that problem aside and imagine the observational experience alone. What would it have looked like if Earth stayed still while everything else genuinely orbited it? The most immediate consequence would show up in the length of a year. In a heliocentric model, Earth completes one orbit around the Sun in 365.25 days, and that steady orbit is what gives us stable, predictable seasons.
In a fixed Earth model, the Sun would need to physically circle the Earth once a year, while also accounting for the tilt that creates seasonal change. Ptolemaic astronomers actually built this into their model, with the Sun looping along a separate track called the ecliptic.
It worked on paper, but it required an increasingly complicated set of circles to stay accurate as measurements improved over centuries. And that complexity is exactly what eventually broke the model. In 1543, Nicolaus Copernicus published On the Revolutions of the Heavenly Spheres, proposing that the Sun, not Earth, sat at the center. His model wasn't perfect either, since he still assumed planets moved in perfect circles. But it was simpler. Fewer circles, fewer corrections, fewer arbitrary fixes needed to match what astronomers were seeing in the sky. Then, in 1609 and 1619, Johannes Kepler refined the picture further, showing that planets move in ellipses, not circles, and that they speed up and slow down depending on their distance from the Sun. Suddenly, the math wasn't just simpler. It was exact. The final blow came from observation itself. In 1610, Galileo Galilei pointed a telescope at Jupiter and saw 4 small points of light, shifting position night after night. They were moons orbiting Jupiter, not Earth. If everything in the universe had to circle our planet, this shouldn't have been possible.
It was direct visual proof that at least some bodies orbited something other than Earth. So, if Earth really had been the physical center, what would society have looked like differently?
For one, navigation would have evolved along an entirely different mathematical path. Sailors and astronomers historically relied on geocentric models for centuries, and it worked adequately for local timekeeping and basic celestial navigation.
But as ships traveled farther and measurements grew more precise, the errors compounded. A universe that resists a false center produces small, cumulative discrepancies.
Over decades, those discrepancies would still show up in trade routes, calendars, and eclipse predictions, the same cracks that eventually forced astronomers toward a better model in our actual history. There's also a deeper cultural layer. Geocentrism wasn't just an astronomical claim. It carried theological and philosophical weight, reinforcing the idea that humanity sat at the center of creation, that everything in the heavens existed in relation to us. When Galileo's evidence directly contradicted this, the conflict wasn't just scientific.
In 1633, the Roman Inquisition tried him for heresy and placed him under house arrest for the rest of his life, specifically because his findings threatened a worldview where Earth's centrality was assumed to be self-evident. If Earth truly had been the center, that worldview would never have been threatened at all. There would have been no crisis, no trial, no centuries-long tension between observation and doctrine. The philosophical model and the physical reality would have simply agreed. Instead, what we got was the opposite. A universe that quietly resisted every attempt to place us at its center, forcing better mathematics, better instruments, and eventually a complete reorganization of how humanity understood its place in the cosmos. We didn't just lose the idea that Earth was the center. We gained something more useful, a model that actually predicted what the sky would do next. Maybe that wasn't a demotion.
Maybe it was the first real evidence that the universe was worth understanding on its own terms, not ours.